I finished up with this board last night, and this morning my bag of parts has arrived, so I should have everything I need now. So here is a high voltage cap for this guy. These are rated for 1600 volts, just like the original. And let's see, here's a 1000 volt cap to replace that guy. And these are to replace the multi-section can capacitor here, and that's a single section down in there, and that guy there for the voltage doubler. Got some safety caps, go across the AC line and replace that one I clipped out when I first powered it up, this guy down here. And I'm going to try using this in place of the fusible resistor, where I currently have this big guy, 2.2 ohm, and should be able to handle the wattage. Alright, these may look like resistors or maybe inductors with the odd coating, but these are actually modern fusible resistors. And let's see, new tip for the soldering iron. And it turns out they actually have decent prices on 9-volt batteries. Certainly a lot better than my local convenience store. So, got a new one for my Fluke, and one for the GE coaxial remote control I got recently. Now that I've got all my parts on hand, it's time to make a few modifications. Here is the original schematic, showing from the AC plug through the power switch into the voltage doubler and tube filament string. So, changes I want to make. One, make this a polarized set. Right now it's unpolarized, and one side goes to the chassis. So I want to make this polarized so that the neutral side goes to the chassis, assuming the house is wired correctly. And I also want to move the power switch, instead of being on the neutral side, to be on the hot side. I want to remove this 54 ohm 20 watt candome resistor, this big guy here, and I want to replace the seleniums with silicon diodes and use a more modern fusible resistor type. Now, when I did my T-102 a few years ago, I worked out all the details of how to make this happen. And I'm going to do it again, basically the same way. So, this becomes polarized. Now, how do we do that? Well, I happen to have some new old stock polarized cheater cords, so I can install that on the back of the set. But that has one of the pins being larger, so what I'm hoping I can do is slide a sleeve over that to increase the diameter. If that doesn't work, I'll see if I can dig up a plate of similar dimensions that's polarized, that has the two pins on it. I've already rerouted one of the wires, assuming that I'll be able to modify this one. So this wire down here, I want to make that neutral, and I ran the wire so it's going directly to this chassis, no switch. Before, this was going off to the, or rather this side is going off to the switch, so this is going to become the hot side. But I'm going to have to modify where the other end of this goes, because right now the other end of the power switch, it goes directly to the chassis. Instead, that's going to run back down into this area. Now, I need to mount some new stuff down here, so what I did is I went ahead and drilled out some of the rivets. So there was a little terminal, one lug terminal strip there, so the fusible resistor was installed. I took that out, and I drilled out the rivets for this big candome resistor, so it's coming out. The other end is going off to the tube filament string. So once that's out of the way, mount the terminal strip down in here and mount as much as I can down in there. Ideally, I'm going to mount not only the safety cap, this guy, and my 1N4007 diode and CL90 for the filament string, but I'd also like to start putting some of the power supply stuff down there. Right now, two selenium rectifiers. One's been removed. It was up here. The other one's still down here. And then we've got these two big caps. That's the voltage doubler. So currently, two big can capacitors, two big honkin' seleniums. New stuff, much smaller. Diodes, very small. Caps, fairly small. So instead, I could forget about these two, forget about two seleniums. I could mount it all right down in here. We won't have this big thing kicking out all this heat. And we got all this room down in here. So I might mount a nice long terminal strip here. I should be able to mount all this stuff right down in here. And then we'll just have B plus coming out of here and going off into the rest of the set. And these, I'll probably just take them out to increase the airflow through the set. Twist locks, just untwist these and run some of the wires down here as needed. Or actually, no, I take that back. I won't need to do that. I'll just run the B plus wire out, and that should be a much neater setup. Here's a look at the back of the set with the old original power cord that's no good. So what one can do is carefully chip away the old hardened vinyl. Take a new cheater cord, if you can find one, they are floating around out there, heat it up a bit so that the vinyl softens and you can mush it down over the rivets. And they'll line up nicely. But what I wasn't counting on is that it's not a matter of just enlarging one of the pins. The other one needs to be a bit smaller. So this just isn't gonna, neither one of these. So this one is too small to fit, and this one is loose. So I can probably deal with the enlarging one, but dealing with the other one, I suppose I could try to spread that one out or squish this one down. But I'm gonna take a little look around online, ask around. Maybe somebody's got a polarized version of this that I can make fit. I use my heat gun to soften up the remains of the old plug and rip that out of there while leaving these two intact. So if I heat this up, and I'm lucky, I'll be able to mush it down over those and a nice new polarized power cord. While I was at it, I also took off the antenna. I've seen a few sets, in fact I have another set with an antenna on the back like this, but I don't think they came out of the factory like that. Dealers may have installed them, because I've seen several that had exactly the same type of style installed in the same place, but pretty clear they just took some sheet metal screws and just drove them right through the back and right through the tube chart. I'm guessing that was a popular option, because otherwise you don't have an antenna and you gotta hook up the screw-in terminals to an external one, and this is a portable TV. It's kind of nice to have it all self-contained. Antennas not in the greatest shape. They're not brass, they're steel, and they're kind of pitted. I suppose I could spend some time and clean them up. I don't know. But the main reason I took it off was just so I can get at the paint on the back of this. I've been making some good progress on the main body of the chassis. Got the caps replaced up in here. And I've also been cleaning up the wires, which were covered in goo. Whatever type of insulation they used on these sets seems to get sticky over time, then all the dirt sticks to it. So I've just been using some denatured alcohol and Q-tips and got that pretty well cleaned off. And while I was at it, I also removed some of the wires that were going to the old seleniums and the two caps in here. All of that I propose to replace on a terminal strip down in here. Now some of you may be thinking, well, the original caps seemed to reform and the set was playing okay. Why go to such lengths? Well, now that I can really get down in here, take a look at that cap. You can see there's some white substance there, which is very likely the electrolyte that has oozed out and dried up. Now that capacitor with the cardboard cover is pretty darn important because all the power for the TV, other than the tube filaments, goes through that capacitor. That's C502 right there. So AC, fusible resistor, and that cap. Then there's 2 seleniums, and then another cap, choke, cap, and that is B+ power for this set. So it's pretty important that that capacitor be in good shape, obviously, since all the power goes through it. So that's why I'm going to be replacing it. But I'm also curious, since the set did seem to play okay, and it did form up. Now, while I was forming it up, this is the capacitor I was feeling that was getting warm. And this one did not, well, this one may have, but it's covered in a cardboard tube, so I wouldn't necessarily been able to feel it. So what I want to do is unmount this cap and analyze it in more detail. I want to check it for leakage and check it for capacitance. Here it is out of the set, so we can take a closer look. Sangamo, made in USA, dry electrolytic, 100 microfarad, 150 volts DC. And yeah, it's definitely oozed out some crud. I've got it hooked up to my multimeter that can measure capacitance, and it does show about 130 microfarads, which is within spec. These were usually rated for plus 80% and minus 20%. Although an ESR test is fairly meaningless when it comes to a capacitor of this type, I figured, what the heck, I've got it handy, so I hooked it up, and we got about 10 ohms, which is well into the red for a 100 microfarad cap. Solar. Alright, let's see what the solar vintage capacitor tester has to say. Check for leakage first. So it actually doesn't have leakage, which is kind of what I suspected. And as for the actual capacitance, it's really a bit beyond the range of this device. But what we can do is the power factor. I believe those works. You should adjust this for the largest eye opening, and I've got this as high as it'll go to get that full eye deflection. Now that's a loss. I do believe that the lower the better. So this is sort of equivalent to ESR, except this isn't at 100 kilohertz like that little tester does. This is at 60 cycles. So this is a really, really inefficient capacitor. So we're not getting enough power going into the set when we're using this, which is curious because it did measure a full B+ when I first powered this set up and had the meter attached to it. But I don't doubt that this will work better, a heck of a lot better, and that this will continue to fail over time, and it's going to leak more and more electrolyte, and this will get warmer and warmer, because when you get power factor loss, that loss is being translated into heat inside this capacitor, which will make it fail even sooner. Now let's see how the new capacitor tests with the same device. So first, leakage. Alright, no leakage on the number 2 position, that's good. Check for capacitance. Nice, strong, full eye open, right about there. And that is with the power factor at 0. As I start turning the power factor up, the eye actually starts closing. That's what you want to see in a good, healthy capacitor. The lower the power factor, the better. And this has a power factor of 0. Much better than the other cap. So this will allow power to go through it with much less loss than this old cap. Now I'm working on rebuilding the power supply and filament dropper in this area. I removed the big can dome resistor that was down in there, which freed up a couple holes. And I just happen to have a terminal strip. It fits exactly on those holes, so I'm going to mount it in like so. So, which is from an old TV. I'll clean off the remains of the old wires there. And what I'm doing now is working on laying out my parts to see how they might fit. One consideration I'd like to make is to keep heat away from the capacitors if possible. So, for example, I would like to use a current inrush limiter, something like a CL90, in conjunction with a resistor for the tube filaments. So that is what we see here. Thermistors get hot, and I don't want to put one like right next to a capacitor because capacitors don't like heat. It will shorten their life. So what I figure I'll do, I'll also want to consider the orientation of the TV. So this is the bottom. So the heat will go that way, so I don't really think that'll be an issue. So it's just a matter of keeping them away from each other this way. So I figured I'll just stick one at the end of the terminal strip. Now, originally I was proposing using a CL90, which is 120 ohms cold, and steady state at 0.6 amps, it'll be around 5 ohms of resistance. So, could use that. However, more recently I've been using these guys, which are 220 ohms cold, and about similar resistance when they reach 0.6 amps, and they're smaller. But check this out. This is the latest batch I got. Same company that makes this, Amitherm, I think they're called. Also 220 cold, and about 4 ohms at 0.6 amps, and check out how small they are. So I think that's a winner for sure. Also fairly inexpensive, and definitely a lot smaller than the old CL90s, and they have about twice as much cold resistance. So the whole point of this is that tube filaments have much less resistance when they are cold, so when you turn them on, there's a current surge that goes through it. It's nice to suppress that if you can, to protect the filaments, especially on the picture tube. So nice to use one of these in series if you can. So one of these plus one of these replaces that, and two of these replace two of these. And this is my new fusible resistor, and here are the two caps for the doubler. So this is the smaller one that goes in series with the AC line. That's that guy there, and then the bigger one needs more voltage because the voltage has been doubled. So both the same capacitance, but this has higher voltage rating, 300 volts, or sorry, 350 volts versus 200 volts. So the question is, do I have enough terminal strips to accomplish all of this? I hope so. So two of these terminals I have no choice, they're going to be ground. No way around that. Fortunately, not too many of these devices actually get grounded, just one of the diodes and one of the capacitors. So that might be where things get a little tight. If needs be, I can maybe put a little connect some of the parts floating in air. But I think I'll be alright. So I'm going to start laying out these parts, I guess. Well, here's what I came up with. Not the prettiest thing, but it's good enough to try out. Had to be a little more creative than I expected because of things like this plastic shaft that runs through here for a horizontal hold. So this will just fit in like so. Those old mounting holes. And those caps just clear that shaft. And the hot components, well, we got this guy sticking up here, and the other one I just kind of had to fold in back here. So what I want to do is, once I get this set back together, is just hook it up perhaps just temporarily to see how hot it gets and maybe readjust if necessary. Also, I placed an order with Antique Electronics Supply for some goodies, including a polarized plug, AC interlock. Very common, dirt cheap, but it's not quite the same as the original, which was mounted on a plate like so, flush to the back. These come with this metal surround, and the wafer is a small piece in the back. So I added some brass sleeves there to extend it out. And I'll have to put the cabinet kind of back together to see if it works. I mean, certainly it works like this on the bench, and I can plug in polarized cheater cord, no problem. What I'm not sure about is, with it mounted like this, with this metal sleeve around in these standoffs, will it fit back together properly? Because the original didn't have that around there. If not, we'll deal with that when the time comes. Also, to fill out my order, I picked up some caps. They got pretty good prices on mica caps, so I picked up a bunch of the values. Also got some of these Illinois capacitor 0.022 microfarad. Nobody seems to carry these. Allied Electronics, where I got all my other yellow axial lead capacitors, doesn't have 0.022 for some reason, so I grabbed a bunch of those. And I got some of these terminal strips. So if I'm not real happy with the way this works out, what perhaps I can do is instead use maybe two smaller ones. Mount one something like that, and maybe mount another one over here. So in other words, use two separate ones, like kind of running at an angle back this way. Give me more room to put the components, so I could like put all the components to get warm on this terminal strip, and put the caps and the diodes on this terminal strip, something like that. But before I do that, since I already got this put together, I want to see how this actually works, and see that these two components don't fry up, and that the filaments seem to be running with the proper amount of current. So I went ahead and removed the second cap as well, so those are the two caps that are now down here on this terminal strip, which frees up a ton of space up here. So I could also mount some components up in here if I chose to. So take these two caps out of here entirely, put a terminal strip up in there. It's another option, which leaves me one cap to deal with, 3-section guy here. One of them is the final filter cap. So I got the two on the terminal strip. I got this guy and that guy on the terminal strip, but there's one more big 100 microfarad I gotta stick somewhere, and then two smaller ones. So again, I could mount a terminal strip over here and stick some caps in, or I could rebuild that, of course, but it is a pain to get at.